So dear 11th class students, now we are continuing complex numbers. So yesterday we have discussed geometrical representation of a complex number. We have defined argument of a complex number. Now we are going to discuss another topic in complex numbers, that is polar form of a complex number. Polar form or trigonometric form of a complex number. So now, dear students, you see here, it's the organ plane. This, there is a point pxy whose distance from origin is, say, r units, and this point P represents the complex number z x plus iy, and let theta be the argument of complex number z, right? Then we know that from trigonometry we know that sin theta is equal y by r, cos theta is equal x by r from trigonometry. So what does this imply? Implies x is equal r cos theta and y is equal to r sin theta. Did you understand? Now let us take z, the standard form, which is x plus iy. Now you replace with x and y. X value is r cos theta plus I into y value is r sin theta. So if you take r common, then you will have cos theta plus I sin theta. This form of a complex number, r into cos theta plus I sin theta, this form of a complex number is known as trigonometric form or polar form of a complex number. Here in polar form, we mean by r is mod z and theta is argument of z. Did you understand? Right. Now we are doing some problems relating to polar form. Here a complex number will be given in its standard form. We have to express it in polar form. So for example, the standard form of a complex number is, say, example 1, minus 3 root 2 plus 3 root 2i. This is a complex number whose polar form is required for us. So whenever you are required polar form, immediately need to find r and theta. So solution, r is mod z, we know, just now I discussed. So root over minus 3 root 2 the whole square plus 3 root 2 the whole square. Mod z is root of x square plus y square, right? So this is equal to root over 3 square is 9, 9 root 2 whole square is 2, 9 2 is 18, 18 plus 18 is 36. So r is equal to 6. Now you have to find argument of z. Okay. Now the complex number z is equal minus 3 root 2 plus I into 3 root 2. It is represented by the point P in the organ plane, which is minus 3 root 2 plus 3 root 2. Right? Now this is a point in second quadrant. So please do remember whatever I discussed in the previous class about argument. So P belongs to Q2. Then first of all you have to calculate tan alpha. So here R value you got 6, keep it aside. Okay. Now you have to calculate tan alpha. So tan alpha is equal to modulus y by x modulus 3 root 2 by minus 3 root 2, which is modulus minus 1, which is 1. So tan alpha is equal 1. So plus alpha is equal pi by 4. Did you understand? Now as P belongs to Q2, as discussed in the previous class, argument of Z is pi minus alpha. We have discussed yesterday this in the previous class. So this is equal to pi minus pi by 4. 4 pi minus pi, 3 pi by 4. So argument of Z is 3 pi by 4. Now, therefore, the polar form of complex number Z is equal R into R value, how much did you get? 6 into cos theta, that is cos 3 pi by 4 plus I sin theta, I sin 3 pi by 4, which is R value you got 6, so you can put 6 into cos 3 pi by 4 plus I sin 3 pi by 4. This is the polar form of the given complex number. Did you understand? If you want, in another step, cos 3 pi by 4 sin 3 pi by 4 values you can substitute. Understood? Our next problem is Z is equal 1 plus I. We have to express it in polar form. So we immediately calculate mod Z, which is R. Root over 1 square plus 1 square. So root 2. Now you have to go for argument of Z. So this complex number Z will be represented by the point 1 comma 1 in organ plane, which belongs to Q1. So tan alpha is equal mod y by x equal to mod 1 by 1, which is 1. So tan alpha is equal 1. So alpha is equal pi by 4. In first quadrant, alpha is equal to theta. Therefore, argument of Z is equal, theta is equal pi by 4. Therefore, polar form is Z is equal R into R, how much you got? 2, root 2. Root 2 into cos pi by 4 plus I sin pi by 4. Did you understand? So this is the way of expressing a complex number in standard form to polar form.